Hello, everyone. I'm Frank, and welcome to Frank Puzzles. And this is today's very hard puzzle, and it's called Liar Exum's Cipher by Chris Tounet and RDRD. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have X sums, where clues outside the grid represent the total of the first X digits in that direction, with X being the digit in the first cell seen. So, for example, if this were, say, a 5, and this were a valid X sum here, HJ, that means the first 5 digits in this column must add up to H being the tens digit and J being the ones digit. And the reason why I specified if this is a valid X sum is because we have liar X sums, where for each row and column with clues, 2 clues are provided. Only one of them, that is top or bottom or left or right, is correct. The other clue is lying and cannot be correct. So that means in every column, in every row that you have a clue, one of them must be true and the other one must be false. So that means in column 4, either HJ is true, going this direction, or this question mark J must be true, going this direction. We are not certain which one is which. And finally, we have Cipher, where clues are encrypted. Each distinct letter represents some unique digit from 0 through 9. A question mark is a stand-in for any digit 0 through 9, but for a single digit or double digit number, the first digit may not be 0. So, for example, this question mark D means that you have to have something in D add up to be the X sum, essentially. Or if this is question mark K, you must have something with adding up to a tens digit, which is not 0, and K. So, and again, you cannot have the first digit be a 0. If you have a question mark, or if you have an H question mark, or a question mark B, or DD, or an HA, or BA, or any of those, you cannot have essentially the first letter be a 0. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, first thing I see is we have A or AA is valid. B or BB is valid. C or CC is valid. D or DD is valid. E and EE is valid. F and F or FF is valid. G or GG is valid. H or H question mark is valid. So that means A through H can never be 0. We have J and K are at the ends. So one of J or K is a 0. Also, to add up to a single digit, you can only have the X sum in the X be 1, 2, or 3. And the reason why you know that is what is 4 digits, and they have to be unique, adding up to. It has to be at least 10. So, Right. And the thing is, so 1 through 5 cannot be the tens digit of in the x sum, right? Because the x sum can only add up to 40 something at most. So we know that means at most 4 digits can have the can have the AA, BB, CC, DD, EE, FF, GG, or HX as a valid sum. The other ones have to have the singletons as a valid sum. But again, you have to have 1, 2, or 3 be that way, right? Well, in box 1, we can only have 3 digits from 1 through 3. So we are guaranteed 3 of these digits have to at least have a tens digit here, right? We don't know which ones. Actually, I guess it could be 4. It could be 4 with A and F. So that is possible. So you could have A and F, 1 out of B or C, 1 out of G or H, or actually, so A and F could be valid as a singleton. Basically using 1, 2, or 3. And then you could have 2 more in B, C, and G, H. Which would mean that you could have if you had A, B, and C all valid as a singleton digit sum, that means this would have to be 1, 2, 3 here. So D and E could not be valid as a singleton sum. That means DD and EE would have to be valid. GG and HH would have to be valid. So then DE, G, and H would have to be 1 through 4. Okay. Also, one thing we know is B or H has to be 1 through 4, or both, right? Both could be 1 through 4, because B and H are here and B and H are here, right? So one of them is valid. So either B or H is valid as a tens digit. Both could be. Um, hmm. Do we have anything else? Oh, we have D. D has to be a ones digit. Sorry, a tens digit value. So D has to be 1 through 4. I mean, technically, you could have 2 digits adding up to it. Can you? Yes, 2 and 1, right? That is possible. Or you could have a 1 here. So this could be 1, 2. We don't know if D's correct, right? What can you not have? Say this was not valid here. If these were valid ones to give you a singleton. That means only one of these could be. So you could have that one being valid as a singleton. Hmm. You would have to have a, so for double digits, you would have to be 11, 22, 33, and 44. H doesn't have to be though, right? Hmm. That's interesting. That's interesting. So what happens if this is the one of the 1, 2s or 3s, right? Oh, that's another thing. Huh. If you have one, okay, so for one thing, if A and F are the singleton values are correct, that means it has to be 2 or 3 here, right? The thing is, to have a 1, that means that value is a 1, right? Um, that would mean, so say, okay, say A and F did not have a valid value to make it a singleton. So therefore, FF would have to add up to a sum. AA would have to add up to a sum. So A and F would both be 1 through 4. We know D has to be a digit from 1 through 4. And then one of B or H is a digit from 1 through 4. So that means one of them would have to be, one of them would definitely have to have a green. And these would have to be valid. So then how would that work? So you'd have a green here. D could be a red. E could not be, would have to have a green. And then you'd have one of B or H, and then one of green. But the problem with that is, right, one of B or H has to have a 1 in it. But the problem is that AA, FF would both require the tens digit to be 1 through 4 because they cannot be true in their respective row and column. D could not work. Um, so that, I mean, well, D naturally always will be 1 through 4 because one of these x sums is correct. So FF is correct here. So this basically not being 1 through 4 means FF is correct, AA is correct. G and C could be valid, and one of B or H could be valid, right? So C is G are not C and G here. But the problem is this being valid this way. So we have AA is one of 1 through 4. D is 1 through 4. F is 1 through 4. And only one out of B or H has to be 1 through 4. But if that were the case, if that's the case, that means E has to be a valid value. But so actually that means C and G have to be valid values. But the problem is one of those values is a 1, which means C or G has to be a 1, which means A, D, and F are guaranteed to be 2, 3, and 4, but then that would mean 5 has to be in a tens digit somewhere. So that's the reason why this cannot be read. It has to be valid for both of these. So this has to be then. So A is valid. Or A, yes. This is specifically a valid number. And it cannot be 1, because then A and F would have to be 1 as a valid value. Well, it could be 1. No, it can't be. This has to be a 2 or 3, which makes A or F or both valid. Can you have B and H be valid? Is kind of the question, right? As a tens digit is what I'm asking. So that would mean red here, red here. Right. So with this green being here. So if you had, again, if you had it as red, the problem is AA and FF both have to be 1 through 4. You're guaranteed 2 digits that have to be 1 through 4 here. If you don't have, if you have this as red, you would have to guarantee right. So either you have 3 reds here, which guarantees you have 1, 2, or 3 here. Um, Say you had these be green. That means none of these could be green. They would be red. So, and these would be red. I don't think that works. Right? Because B and C. So G and H would mean that these cannot add up to a singleton value. So G has to be 1 through 4. H has to be 1 through 4. Same with D and E. Right? But then this has to be, one of them has to be 1. Because you have a value of 1 there. So this cannot be 3 greens here. So that means, can you ever have 2 1s here? A green here, a 1 here, and then not 1 be one of those? So D can obviously be red. So say you had a green here, and then you had like a 1 in one of these spots. So maybe a 1 here. That would make this red. Then one of these is red, one of these is green. This would imply G has to be 1 through 4, D is 1 through 4, C is 1 through 4, and then B could be 1, and that could be possible. What happens if these are both green, and then we have green there? Well, one of these would have to be 1. So if we have 2 greens here, these are both red. D would have 1 through 4, so we could be none there, and then we could have E being there, and this being 2 or 3. So I think we're guaranteed A and F have to be 5 through 9. Because either we have 1 digit here that's not 1. So say we have 1 digit here that's not 1. So red, red. We know D has to be 1 from 1 through 4. So that could be red also. So B is 1 through 4, G is 1 through 4, H is 1 through 4, D is 1 through 4. Which would mean E cannot be 1 through 4, so EE cannot be valid. So this doesn't work. You could have one here, I guess is one thing, though. You could have green, red, red, red. So D is 1 through 4, C is 1 through 4, B is 1 through 4, and G is 1 through 4. Which means E cannot be 1 through 4, so it would have to be... So that's possible. So you're guaranteed one of these have to be a 2 and 3. Or, yeah, you could have this be green, green, right? With one of them being 1. That means these are both red. So B is 1 through 4, C is 1 through 4, one of G or H is 1 through 4, and D is 1 through 4. So therefore, that means E has to be a 9, 8 or 9. So you could have that scenario. I think, therefore, this D has to be red, period. Can you ever have D as a green here? If D is a green... Say we have red, red, red here. Can you have green? That means B is 1 through 4, C is 1 through 4, E is 1 through 4, and then one of G or H is 1 through 4. Well, you could have this be the 1, right? You have 1 here. This is green. These are both red. And one of these is green, one of these is red. So you'd have G as 2 through 4, B as 2 through 4, C as 2 through 4, and D as 1. So that is possible. Interesting. Can you have B and H both be valid tens digits? So then that would be red and red there. D is valid as a tens digit. You could have green here and green here, which would make C as the last 1 through 4. Right. So the problem with having 3 greens in a row or in the box is one of them has to be 1. So it basically counts essentially as a 1 through 4 digit, a tens digit, which sort of defeats the purpose of having it, right? So that means in box 1, which is why this has to be green here, right? That means A and F are both 5 through 9. So this must be the valid X-sum clue. And this is invalid. This is the not true one. If you have a 1 here, it's guaranteed to be part of... We know D has to be 1 through 4 because it must match in row 7 as one of the tens digits. But it could be green, it could be red or 1. It cannot be 2 or 3, I don't think. And the reasoning is first of all, D can match this. If we have one more 2 or 3 in this box. If it's so that means you can have only one more of these digits match a sum that's a singleton digit, which is not 1. So because of that, the rest have to either match a 1 or must match a tens digit. Right? So the 2 or 3 can match so 1 out of B, C, G, and H. Right. 1 out of B, C, G, or an H can be 5 through 9. The rest have to either be 1 or match the tens digit, which would be 1 through 4. So 3 out of B, C, G, H must be 1 through 4, which means E cannot be 1 through 4, right? Because D is 1 through 4 because it matches a tens digit. If you can only have in box 1 more 2, 3, and you could have a 1 as the X sum, which would match a 1 for value, or you could have, or they don't match. You have the 2, 3 here, right? And then the rest would be 4 through whatever, which obviously doesn't add up to a singleton digit. So therefore, 3 out of the 4 of BCGH must either be a 1 or match a tens digit, which is 1 through 4. And since D is 1 through 4, that means none of the other digits can be 1 through 4. That's why A and F have to be 5 through 9. E has to be 5 through 9. So this must match a digit here, and it cannot be 1. So this is 2 or 3. So B or C cannot match 2 or 3. That means 1 out of G or H has to match 2 or 3. B, though, could be a 1. So you could have a green 1 there. C, I don't think can ever match 1. Well, C could match 1 also. So remaining digits of... Can this ever be 4? I guess it could be 4 also, yeah. You could have 1, 4, 5, 6, 7, 8, 9. So we have a definite 2 or 3 in one of these digits here. So this must be a 2-3 pair here. Obviously this cannot be 9. It cannot be 8, because this must add up to a singleton digit. This can't be 9 or 8 either. So this is 1 through 7 this way. Rest of column 1 is 1, 4, 5, 6, 7, 8, 9. This cannot be 8 or 9, so this is 1 through 7 also. If you have a 3 here, does that work? If you have 3 there, I don't think it does. You have to add up to 2 digits and both using 3. So it'd have to be 1, 4, and 2, 5 are the minimum. They have to be distinctly different digits too. So it does not work. You cannot have 3 there, because minimum is 3, 1, 4 one direction and 3, 2, 5 the other direction. So because it can't be 3, 1, 5 and 3, 2, 4, because then they would both add up to 9. So this can't be 3. This is 2. This is 3. So E, so this is 2, which means 2 cannot be here. 3 has to be one of these. This can't be 2 this way. You could have 2 and 3 here. You could have 2 and 1. You can't have 2 and 1. A has to add... A and F have to add up to 5 through 9. So F has to be 6 through 9 here. A could be 2, 3, 4, 5, 6, 7, so that works. E has 3 digits adding up, so E has to be at least 6 through 9. So it could be 1, 2, 3, 1, 2. It can't be 7. 3, 1, 3 doesn't work. It could be 3, 1, 4 or 3, 1, 5 or 3, 2, 4. We don't know which. So E is 6, 8, or 9. This cannot be 1 here. This could be 1 there. If this were 1, A would have to be 3, and then we'd have too many digits having to be 1 through 4. B can't be 1 for the same reason. So B is not valid as a singleton digit. So B has to be a tens digit. So this has to be valid, which means B is 1 through 4, guaranteed. Um, let's see. So this E is valid. Double E is not. DD could be valid, or it's D that's valid. We don't know. It could be a 1 there, right? You could have 1 and 2 here. And then this could be 3 and 1 here. So one of G or H has to be 5 through 9. B is 1 through 4. I guess, yeah, one of G or H is 5 through 9. C or... Wait, so... Right. One of G or H has to be... Oh, that's not true. That's not true. You could have 3 and 1 there, right? So then G and H are necessarily both 1 and 4, 1 and 1, 2 digits from 1 through 4. Oh, wait. No, one of these has to be a 3. So one of them has to be 5 through 9. Okay, so... Hmm. Hmm. So we know B as a tens digit is valid. H is not necessarily, but it could be. That means one of these is 44, right? Yeah, one of these is 44, except for H. So G... Huh. If G... Yeah, so one, if 4 were A through G, you have to have 44 there. So if B is 44, this would be 44. This could not be 1. Sorry, this would have to be 1. So B cannot be 44. Because I would have to have 8 here, adding up 8 digits, and this would have to be 1 remaining. Okay. So the 1 has to be, unless it's H, which could be the case. You're guaranteed a 1 in the 44 category. Interesting. So if C were 4, that means 1 would have to be here, and this would have to be 8. And that could work, because this could be 1 here. If D is 4, that means this is 8 and that's 1, and that could work. G cannot be 4. Because if G is 4, you have to have 3 digits adding up. Oh, what does this 3-digit number add up to? It has to be a single digit, right? There's no 2. So the 3, 1, so G or H have to be 8 or 9 if they are the singleton, right? Or if they are, yeah. Oh, so it necessarily forces 1 to be there, right? If you have 3 here and it's 4, 5 at minimum, that adds up to 12, which defeats the purpose of having the singleton digit. So it has to be 3 with 1 being one of these digits, so that eliminates 1 in the rest of the box. So this is guaranteed to be red. So C has to be 5 through 9 also. We have 8 or 9 here. So C has to work. B and C do not work. D could work. So H could be 4 or D could be 4. We don't know which. G cannot be 4. So G could be 8, 9, or it's 1, 2, or 3. H could be 8, 9, or it could be 1 through 4, because this could be 40, right? No, H cannot be 4. Even if this, yeah, H cannot be 4. So therefore, D has to be 4. So D is a 4, and it's either 44 this way or it's 1. Wait, it can't be 1. So then it has to be 44. So D cannot be... Okay, so again, the reasoning is this 3-cell number here has to have a 1 somewhere in the 3 digits. Otherwise, it's 3, 4, 5, adding up to 12, which means that this clue doesn't work with a 3, which means we have too many digits requiring from 1 through 4. Because then this would be GGHH would both be 1 through 4. And we know AAFF and EE, or sorry, DDBB and CC are all 1 through 4 also. Actually, yeah, C is 1 through 4. Apologies. That's 1. It cannot be 4. It's 1 through 3. So J and K have to be... So again, the only way you can have H... this is also... this H cannot be 4, 40-something. G cannot be 40-something, because 5 digits is never going to add up to 40-something. So because of that, we know D has to be 4, which means DD works, so this has to be 8 here, and that adds up to everything but the 1. So this is 1 here, which means this cannot be 1. E has to be 20, has to be 3, 2, and 4 then, to add up to 9. So no 1 or 4 here, no 1 here. E adds up to 9, which means G and H must be 3, 1, and 4, adding up to 8. So that means no 9 here, no 9 here, no 9 here. This cannot be 7, this can't be 7. These can't have a 4 in it because we have 3, 1, and 4 adding up to 8. So one of these two is 8. F cannot be 8. F have to be 6 or 7. A can't be 8. So F has to be 2 and 5. And this can't be 2 and 6, so this must be 2 and 3. So A is 5. F is 7. That means we have 6 and 0 left is the ones digits, which would be J and K. This can't be 5. So this is 3, which makes this 3, 1, 4 as a pair. That eliminates 3, 1, 4 in the rest of the row. So this is 2. This is 4. So 3 is one of the valid ones. So that means these are all essentially red. H then cannot be 1, 2, or 8. G is 8. And H has to be 1, 2, or 3. So either one works for B and H. 4 digits means, so this is valid. This is not valid. And G is valid. GG is not valid. Okay. No 5 remaining in row 1. We have 5 through 9 remaining in row 2. We have 6 through 9 remaining in box 1. And this has to be 5 through 9 here. So what is H at most? Then this way. H has to be 4 digits. So 4, 7, 8, 9 means H is 1 or 2. Okay. Hmm. 8 is here, so 8 cannot be here. Remaining digits of column 9 are 1, 5, 6, 7, 8, and 9. 8 obviously can't be any of these. D is 40-something. Interesting. Huh. So B and H are both valid. Huh. So H could be a teen number. I mean, D actually could be 9 also, right? That could work. H and, well, we don't know which one's the valid one and which one's not. Okay, so B does not include a 5. So BB and CC work, so these cannot be 1. They add up to at least 11. So we have 2, 3, 4, 6, 7. No 9, because 7 doesn't work for B. This could be 5. 9 obviously doesn't work because that adds up to 45. But if we had 7 here, this is guaranteed that it has to be at least 36, and that doesn't work. So this can't be 7. So BB has to have 2, 3, 4, or 6 there. Obviously, you could have 2 and 9 to add up to 11. That's valid. 8 is here, so that means 8 cannot be here. So 8 is one of these 3 digits. What else do we have? 8 is one of these 3 digits. E is 9. So either this is something 9, or this is something 0, or something 6. BH would be 12, 13, 21, 23, or 31, or 32. And it could be either way. J means this sum must end in a 6 or a 0. Hmm. You could be missing 4 and 9, or 4 and 8 here, which would add up to 33, possibly, if that's 7. Oh, we have a 5, 6, 7, 8, 9. So quintuplet in row 3. So this has to be 5 here, which eliminates 5 in the rest of the box. So you're guaranteed this is 4 and 5. The remaining digits in the box are 1, 2, and 3. 4 has to be here. 5 has to be here. So you have 4 and 5, which is 9. Interesting. um. D is 4. So one of these is 33. That is interesting. Okay. Can it be BB? So say we have 6 here. That means you cannot be 43 with a 4. So what happens if you have 6 here? Then this can't be 6. We have 33 here, which means this must add up to 12. Well, that can't add up to 12. You can't have 1, 5. You cannot have 1, 5, 7 adds up to 13, which is the minimum for 1. 4, 5, 7 obviously is way too big. So B cannot be 33. That means C has to be 33. It could be 5, 6, or 7 digits adding up to 33. We don't know. We need, that means okay. No, it has to be 7. Because these, if you try to have 6 or less, these 3 digits by themselves add up to 1, 6, and 7, which is 14. So 33 can't be there then. So this has to be 7, which eliminates 7 in the rest of the box. This can't be 7 here. This can't be 7 here. So 7 has to be one of these two, which eliminates 7 here. That means these 7 add up to 33. These 2 must add up to 45 minus 33, which is 12. And it can't be 1 here, so this is 4 and 8. That means this can't be 8 here. This is 1. So this is 6, 7, 9 as a triplet, which eliminates 6, 7, 9 in the rest of the row. This can't be 6 or 9, it's 5. No 6, 5, 6, or 9 there, so that's 8. So this is 4, 5, and 8, which adds up to 17. Okay. So B and H, or H and B, is 12 or 21. Okay. 7, we don't know. So, yeah, and this could be 1 or 2. We don't know which. Okay. Hmm. Hmm. Oh, obviously this can't be 8 here. No 8 here. So 8 and 5 have to be this set. Okay. Um, HB. So this is also 12 or 21 in these rows. Huh. We have HA here, or BA, which would be 15 or 25. Hmm. Yeah, so this is 2 and 5. So we can remove the red uh here. So this is 2 and 5 matching. This is 7 here matching. This is 3, 2, 4. This is 8. We don't really need this. Let's whatever. Let's just do green and red for the valid clues and the invalid clues. Remaining digits in row 9. 1, 2, 3, 4, 5, 6, 9. Okay. That's not very helpful. Hmm. So this is working. 3, 2, 4 add up to 9. This is working 2 and 3 add up to 5. This is working 2 and 5 add up to 7. This is working 3, 1, 4 add up to 8. We have this working. We have 12 not there. We have this working. We have 8 digits here, which 45 minus 1 is 44. So we have this interesting aspect and this interesting aspect. Hmm. We don't know which one's 1 and which one's 2. That's also a problem. We don't know which one's J and which one's K. E is something 9, so it'd have to be at least 19. This would be at least 10 going this way. Hmm. What about D and K? We have D is something 4, and this would be 0 or 6 at the end. So it's at least 14 and at least 10 that way. It can never be just 10 here, though. It could be 16? No. Can't be 16 because you would have to have a 5. So it has to be 20 at least here. Because this can't be... You can't have 2, 3, and 4 here as the X. So it's at least 5 digits, which is going to be greater than 10. Um... The thing is, J and K don't actually have to be invalid clues, right? So there's that. This is 40 something. So to add up to 40 something, you have to have 7, 8, or 9 digits here, right? So either this is 7 or 9, or this is 8 and 9. Um, question mark B. Hmm. So if this is question mark B, it has to be at least, if this one's valid, it has to be at least 31. Um, hmm. What about BH? So this is this one of these is 12 or the other one's one of them's 12 or 21, right? Okay. And again, you cannot have it be valid the other way, too. You have to remember that also. Obviously, any teen with a 5 through 9 or a 10 digit with a 10 unit with a 5 through 9 obviously doesn't work. So we don't have to worry about that. And anything that doesn't have 2 or 3 as a singleton doesn't work. Um, this doesn't work because it doesn't add up to 4. Can't add up to 55 here. No 99. No 77. No 88. Hmm. You have 4 there, 0 or 6. 9 ending 0 or 6. 40 something. Hmm. H is, so you have a 15 or 25 in row 8. You have 12 or 21 valid in row 9. In column 4, it's 10, 20, 16, 26, or any possible combinations of 30s and 40s. Because if it's bottom, column 6 is 12 or 21 also. And column 7 is something 1 or something 2. Okay. The problem is that that each one is a lie. There could be lying swapping sides, right? So we don't have to have one side be just completely valid. Um, uh, hmm. Um, hmm. Hmm. Okay, 2 digits adding up has to add up to 11. So it'd be 2 and 9 if that's the case. 3 digits has to add up to 11. Because it can't be 3, 8, and 9 is the maximum. And it can't have 1 and 5. Oh, that's interesting. So it'd be 3, 2, 6 then, adding up to 11. So if it's 2, it's 2 and 9. If it's 3, it's 3, 2, 6. If it's 4, that cannot add up to 11 because 4 digits adding up to 11 is 1, 2, 3, 5. So it must add up to 22 in that instance. Okay. So it must add up to 22 in that instance. So 22 minus 4 is 18? Yeah. 6 doesn't work. If you have 6, it you can't ever add up to 22. It's 20 for 6 digits to add up to 22. It's 1, 2, 3, 4. Well, actually, you can't have a 1 either. So it'd be 2, 3, 4, 6, 7, 8, which doesn't add up to 22. It's way too big. So 6 doesn't work. How about 4? 4 without 1 and 5. So the other 3 digits add up to 18. I think that is possible. 369, right? 378. Hmm. No 5. Yeah, and no 4. So it would have to be 369 or 378. That would be 7 and 3, 8. But this could be any digit, right? Hmm. Interesting. So this is guaranteed to be 2, 3, or 4. Can this be valid as 12? So if this is valid as 12, the answer is no. If this were valid as 12, how is it going to add up to 12? You have to have 4 digits, and you have 4 and 7 guaranteed, and 2. That's 13 already. Can this add up to 12? The answer is also no. You can't have 2, 3, or 4 here. 5 digits, and 1 digit always adds up to 1. 5 adds up to at least 15. So this has to add up to 21, whichever way you're going. Interesting. Can you have 21 this way? 6 doesn't work. Can 5 work with an 8? Um, 5 and 8 is 13. Which means 21 minus 13. 21 minus 13 is 8. So it'd have to be 134. And the problem with that is that would force a 2 here, and then BB could never add up to 22. So this cannot be 21 and is invalid. Therefore, HB is 21 and is valid. B is 1, H is 2. So then this has to be 4, 5, 8, and 3 to add up to 20. So 3 cannot be here. So this can't be 4. This must be going this way, so obviously 1 can't be there. Cannot be the full 9. Can it be 6 to add up to 21? No, because we have a 7 here. So this is 2, 3. So we're guaranteed 2 has to be one of these digits. Which means 2 has to be one of these 3. That was interesting there. 21 with 5. Does that work? These could be many things, so let's clear that out. This is guaranteed to be either 2, 9, or it's 3, 2, 6. Um, can this be 15? Yes, if it's 5. Can this be 25? Possibly. Let's add first the 21 here. 4 and 7. 4 doesn't work. 4 and 7 is 11, so these two would have to add up to 10, right? 21 minus 11 is 10. But we can't have 2, 8 or 3, 7 there, so this can't be 4. This must be 5, which eliminates 5 in the rest of the column and a row. This is 12. So these have to add up to 9. So we cannot have, it has to, cannot be 5, what can it not be? Cannot be 5, 1, 3. So to add up to, it's 9, right? 21 minus 12 is 9. So it could be 2, 1, 6, 2, 3, 4, and those are the possibilities. Okay, seems reasonable. Still don't have very much here, so this is either 2, 9, or this is 2, 3, 2, 6. Okay. Can this add up to 25? Maybe. Can this add up to 15? So what happens if this is 15? Then this has to be 5, 1 through 4. And then this is 6 through 9. So this can't be 7 here. So 7 would have to be here. No 1, no 1, no 3. This would have to be 6, 8, and 9. So 5 would be not here. This would have to be 6, 8, and 9 here. So this can't be 8 again. No 6, 8, or 9 here. This doesn't add up to 40-something, so this must add up to 40-something. So it'd be 7, 9 here. This would be 1, 2, 3, 4. No 1 here, no 4 here. This can't be 2, because we have a guaranteed 2 in one of these cells, if that's the case. So this looks okay. Huh. Hmm. Okay. So we know that's 5. This has to be 1 through whatever. This cannot have a 2. So it's 1, 4, 1, 3, 4, 6, or 9. Because you can't have 5, 7, 8, or 2. This can't be 3 because of 3 in the column. Can this ever add up to 12? The answer is no. We had 4, 5, and 3 at minimum, so that's not going to work. So then this must be the valid one. This is invalid. And it cannot be 9. Can it be 6? No, because it would have to be the digits 1 through 6, so this must be a 4 here. So that eliminates 2, 3, and 4 as a possibility to add up to 9 here. So this must be 2, 1, and 6. So this is 2 and 9, which means 9 cannot be here. 9 cannot be here either. This can't be 9 anymore. This has to be 1 and 6 as a pair, which eliminates 1 and 6 in the rest of the row. So this can't be 1 or 6, it's 9. That leaves that as 3. So no more 9 here. Interesting. So this cannot have a 9 in either of these spots. So either this is 8 or this is 7. Huh. So this is 4 digits adding up to, this can't be 4 here. 4 digits adding up to 21. So this adds up to 17. Okay. No one here. Hmm. Remaining digits in this box are 2, 3, 5, 7, 8, 9. Obviously, no 9 here, no 3 here. One has to be one of these 3 digits here. This is 3. Remaining digits in the box are 1, 2, 4, 5, 6, 7. No 1 or 5 here. Can this be 5 again? Maybe. Remaining digits in box 7, 1, 3, 4, 6, 8. No 4, 8 here, no 4, 8 here. No 1 here because of 4, 8 in the column and 1 in the column there. This adds up to 17. You could have 179 there. Hmm. Three. Something B. It could be it'd have to be 11 if it's B. This is whatever, that's satisfied because this is 1 there. This is 2 and 9. This would have to be 6 and 8 then. This would be 7, and that does add up to be 5, 2, 4, 1, 2, 3, 4. That seems fine. In which case this would be 7. And you could have 4, 1 here or 3, 1 here. That seems fine. This is the tough part of this puzzle, not the break-in. I was assuming that that would be the case. So again, 17 here. So you could have a 9 here. You cannot have a 9 there. Well, no, you can't. If this is 9, this cannot add up to 8, which is what it would have to, right? So no 9 here. It could be 8. 2 works. No 3, obviously. No 4. 5, 2, and 8 work. So 5 works. 6 works, right? 2, 6, and 7. Well, no, wait. 1 works with 7 and 9 to add up to 17. Plus 4 is 21. Hmm. Uh, hmm. 6 means this would have to add up to 11. So you could have 2, 9. Right, 6, 2, 9 adds up to 17. So that could work. 7 would require 2, 8 there, but that could work. 8 requires 2, 7 there, so that would work. But we're not guaranteed that 2 has to be in one of these 3 digits. Can this be 25? That would mean this has to be... Can it be 4 if that's the case? If we have 25, you have 4 here. That's 13, 9. But then you can't have 6, 6. Or 3, 9 here as 12. So 4 doesn't work. What about 6? 8 obviously doesn't work to add up to 25. What about 6? 1 obviously doesn't work either. So 6 is 15. These 3 would have to add up to 10. So 1, 2, and 7 could work. 3, 2, and 5 could work. Obviously, this is not 6. This is 1, 3 as a pair. That would force this to be 4, 8 as a pair. So no 4 here, no 8 here. So 8 could not be one of these. So 8 would have to be here if that's the case. Which means this cannot be 8 here. So 1, 2, 7, or 3, 2, 5 in that case. And that would add up to 20. Oh, it's 6. Okay, yeah, that's not going to work. If it's 6, then 4 digits adding up to 10 doesn't work. So this cannot be 25 here. This can't be 25 here, so that's not valid. This has to be 15 then. So since this is 15, it's 5 digits. That means this has to be 2 through 4. This has to be 6 and 8. So this is 6, that's 8. Which means no 6, 8 here. No 6 here. This is invalid because it cannot ever add up to 40. So we have this is not valid, and this is valid. So it's 40 something, and it has to be 7. Because 9 is no longer possible. This cannot be 5, 7, or 8. It's 2, which eliminate, and this must be 3, because that's the only place for 3. This is 7, and this has to be 1, 4, so this is 1, that's 4. So no 4 here, no 7 here, no 1, 5. This is 2, 6 as a pair. This can't be 2, no 3, no 7. So this is 5, 8, 9. This is 6, and it must add up to 21, so these have to be 15 to add up to there. So this cannot be 5. This is 6 or 7 with the 8 or 9. Okay. This is 3. So can this ever add up to something B? And the answer is no. It either adds up to 6 or it adds up to 10. So this is not valid, which means this is valid. Okay. No 5 or 7 here, so we have 1, 6, 8. This has to be valid. It cannot be 9 then. So one of these is 9, which eliminates 9 here. Can it be 7? Yes, because that would be 41. Can it be 6? No, because then that would not be 41, 31, 21, or 11. So this has to be 7 here, which means this can't be 7 here. This can't be 7 here. It's 4, 6, 9 as a triplet. So this is 5 and 8. 7 eliminates 7 here. Okay, this cannot be 6 and 9 adding up to 15 because that would eliminate all possibilities there. So this is 7 and 8, which means this can't be 8 here. No 7 and 8 here. It's 5, which makes this 8, which makes that 7. That leaves this as 1, 6, and 9 here in column 6. 7 eliminates 7 here. 20 or 26 here. Is that valid? This is likely the correct one, but I have to double check. Okay, so this one we don't care what's there. We do have to care here, though. So this cannot be 1 here. If this is 1, that makes this 3 and 4, which means this doesn't add up to 40-something. So this is 3, which makes this 4, which makes that 1. So that adds up to 40 there. So that's valid. 1 and 8 cannot be here. So we have to have a 4 there. Remaining digits is 6 eliminates 6 here, so this is 9, which means this can't be 9 here. This has to be remaining digits in column 3 are 1, 2, and 5. Remaining digits in column 2 are 3, 8, 6, and 7. No 7 here because of 7 in the row. Can we ever add up to 20 or 26? Maybe. We don't know what this is. We don't know what this is. Remaining digits of column 8. We have 2, 3, 6, 9, and 7. Remaining digits of column 7. Obviously no 7 here because of 7 in the row. We have 2, 4, 5, 6, 9. This 6, 1, 6, 8 triplet eliminates 6 in the rest of the box. So no 6 there. Okay, to add up to K, you could have 8 here. That could work. And this would be 9. So that is valid. What about any D? So it'd have to be 6 here. Probably, right? I don't know. What about this way? This is probably the most, it is the most restrictive now. So 20 or 26. Obviously could not be 9 here. Can it be 6 here? Then that would be 1, that would be 6. Which would make that 2 and 1. So 6 digits to add up to 20 or 26. Obviously 20 is not going to work. What about 26? That would mean this is 16, which has to be 178, which is not possible. So 6 doesn't work here. Can this be 6? Adding up to 20, something ending in 0 or 6. That would mean this is 1, this is 2, that's 1. No 6 here. So we have minus 9. So 6, these 6 digits would have to end in a ones digit with 0 or 6. That means this would have to be 30 or 32. Can't be 36 because this is 9 already. So it'd be 26? That's not possible. So 30, which would mean this is 15, which would be 1, 8, and 6, which is not possible. So this does not work. So this is not valid, which means the other side is valid. And we already, I think we already showed not 6 doesn't work. Or does it? Hold up. So if we have 6 here and this is 4, that's 9. That makes this 1, 6. So this is 2, 1. And this must, it has to add up to 26 or 20. Can never add up to 20. So 26 here, which is way too much. So, all right, sorry. This is 26, which means this has to be way too much. Because this would, 45 minus 26 is 19, and this is never adding up to 19. So this cannot be 6. This has to be 4. So therefore, 4 and 8, it cannot add up to 26 with 1 or 2. So it must add up to 20, right? So this is 12. So this has to add up to 8. It's 1 and a 7, which can't work. So it must be 2 and 6. So we have 2 and 6. That makes this 1 and 6 there. 2 eliminates 2 here, so it's 1. 6 eliminates 6 here, so it's 9, which makes this 6. No 6 here. This is 1 or 9. That eliminates 6 in the rest of the row. This has to be 3, 5, or 9. Remaining digits in column 5 are 2, 4, 5, and 9 eliminates 9 here. So 9, this makes this 5, which makes this 9, and no 9 here. We have 2, 4, and 8 remaining in column 5. Okay. Can this be J? Okay, so J is 20. So this must be 0, and this must be 6. If you have 8 digits, you would have to have a 5 here. So this does not work in a 0. So this is not valid, which means this is the valid one. So it ends in E, so it's 39. It's something 9. Which means this cannot be 9. Can it be 7? Maybe. 7 digits. It ends in a 9. So that means this must add up to 6 or 16. And it cannot add up to 6 or 16 here. Because 8 and 8, or 1 and 5, could add up to 6 or 16. So it cannot be 7. This is a 4, which eliminates 4 in the rest of the row and box. 4 and 6 is 10. So these must add up to 9. So 1 and 8, 2 and 7. And those are the possibilities. 1 and 8, which cannot be 1 and 8, because that would eliminate all possibilities for that cell there. So this is 2 and 7, which makes this 6, which makes that 7. No 7 here. 2 eliminates 2 here, so this is 8. No 8 here, so that's 1, which makes this 9. No 2 or 9, it's 5. No 2, 7, 9, it's 3. So no 5 here, no 3 here, no 1 here. Okay, so something D is ending in 4. So it'd be 6. Something K. So if this is something D, this is valid. That would have to be 6 because 45 obviously doesn't end in 4. No 7 here, no 6 here, no 2 here or here. So we had, if we had 6 here, so you'd have 6, this would be 8. This would be 3, 5, 1. No 8. Well, we already know this can't be 8 anyways. So no 8 here. This 9 eliminates 9 here, so that's 1, which makes this 5, which makes that 1. Okay, well, that's helpful. That means it can't be 5 here. It's 3, which makes this 5. 3 eliminates 3 here, so it's 8 and 3. 8 eliminates 8 here, so it's 6 and 8. 6 eliminates 6 here, so it's 9 and 6. So does this add up to... Could this add up to something 4? What do we have currently? This is 10. This is... So this would have to have 8 digits. Add up into something 6. Which is not possible, because 9 is no longer possible there. So this must be the valid one. So this is the valid one. This is invalid. And again, this is 10 plus 12 is 22. So to add up to 4 would be 2 here, which makes this 4. 2 makes this 9, which means this is 4 here. 9 eliminates 9 here, so it's 6, which makes this 2, which makes that 6. That leaves a 2 here. 6 eliminates 6 here, it's 9, and this is 7. And that's the solution. Yeah, that wasn't too bad. I mean, I guess you could err on the side of being difficult and saying that this is very hard. So that's possible. It just doesn't feel like it was like that extremely difficult. It seemed fairly, I don't know, not straightforward, but the logic, I never felt like I was stuck, which oftentimes I feel in the very hard puzzles. But I mean, I guess this is a lot of work to do, so the execution could be problematic. But anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.